Welcome to the video lecture series of Grade 10 Chemistry. Today we will discuss about chemical reactions and equations. It is chapter 1 and the topic we are going to discuss is oxidation and reduction reactions. The oxidation and reduction reactions are generally called redox reactions. So what is oxidation reaction? As the name indicates, it is addition of oxygen, or we say it is the removal of hydrogen. So oxidation means addition of oxygen or removal of hydrogen, because in some reactions oxygen are involving, in some other reactions oxygen are not involving. So the reactions in which oxygen are involving, in that cases we can use the first definition, that is addition of oxygen. In some reactions in which oxygen is not involving, in that kind of cases, you can use the second definition, that is removal of hydrogen. So in that case you can define oxidation in terms of removal of hydrogen. So what is reduction then? Reduction is the addition of hydrogen or removal of oxygen. So these are the common definition for oxidation and reduction. So addition of oxygen is called oxidation, and addition of hydrogen is called a reduction. Now, what is meant by an oxidizing agent? In any chemical reaction, some substances are there and they will provide oxygen. So these substances we say oxidizing agent. So oxidizing agent means the substance or a compound which provides oxygen. And also we can say it gains hydrogen. Okay. And what is reducing agent? Reducing agent is the substance which provides hydrogen or gains oxygen. So these are the common definitions for oxidizing agent and reducing agent. Now let us study one textbook example, that is heating of copper powder. Copper powder is brown in color. This is copper powder. This is brown in color. And when you heat this copper powder, okay, basically it is combining with oxygen. So if you start writing equation, Cu, symbol of copper is Cu, and it combines with oxygen. Okay, so we are heating this compound. You can write heat or you can give a delta sign. Both are indicating heat. Okay, so copper is converting to copper oxide. CO, this is cupric oxide, because copper valence is 2 over here. Now we need to balance the equation. Okay, there are 2 oxygen atoms, so I'm just putting 2 on the product side and 2 on the reactant side. Now the reaction is balanced. So in the beginning of the reaction, copper was actually brown in color, and when you start this heating, the brown color substance is changed to black copper oxide or black cupric oxide. This is called a cupric oxide, or you can say copper oxide. Cupric oxide. Copper has 2 valencies in usual chemical reactions. Valency 1, we say cuprous compound. If the valency is 2, we say it is cupric oxide. Now here the valency is 2, that's why it is called a cupric oxide. So brown color substance is changed into a black cupric oxide. So in this reaction, when you look, you can understand that copper is combined with oxygen, which means copper undergo oxidation here. So this is an example of oxidation reaction. Copper is combining with the oxygen. So addition of oxygen is called the oxidation. So this is an example of oxidation reaction. Now the same cupric oxide, okay, you are passing hydrogen gas. Then, so what will happen to the cupric oxide next? So I'm just writing another equation here. Black cupric oxide, CuO, okay, this CuO is allowing to react with the hydrogen gas. This is hydrogen gas. And cupric oxide, as you know, it is solid substance. Okay. In this reaction, cupric oxide will give its oxygen to hydrogen, and it is converting to copper itself, CuO. And this hydrogen is combining with the oxygen, so you will get H2O. Okay. So what happened in this reaction? The black color cupric oxide is converting to, before this cupric oxide was black in color, now it is converted to brown color copper. So in this reaction, loss of oxygen takes place. Cupric oxide has lost its oxygen. So this reaction we say reduction. So copper is being reduced. So this reaction is an example of reduction reaction. Reduction. Okay. Cupric oxide, it loses its oxygen. Loss of oxygen, we say it is reduction. And what happened to hydrogen? Hydrogen gains oxygen over here, gains oxygen. So that is oxidation. So this reaction is undergoing both oxidation as well as reduction. So this reactions together we call it as a redox reaction. So oxidation along with the reduction reaction. So we call this reaction as redox reactions. So what are redox reactions? Redox reactions are reactions in which both oxidation and reduction takes place simultaneously. Okay, so there is oxidation is taking place as well as reduction. Now, when you check this copper oxide, you can say that copper oxide, it contains oxygen already. So this copper oxide, we can say this is the oxidizing agent. Oxidizing agent. So what is an oxidizing agent? Oxidizing agent provides oxygen to the reaction. So a substance, if it provides oxygen to that reaction, we call it as oxidizing agent. So copper oxide is the oxidizing agent. By the time hydrogen, you can call it as reducing agent. So hydrogen is the reducing agent. It is the reducing agent. Okay. Now let us study about another reaction. Here I am going to take zinc oxide, ZnO, okay, and it is reacting with the carbon, and this reaction is carried out in presence of heat. Okay, now can you tell me which is the oxidizing agent over here? Zinc oxide is the oxidizing agent. Why zinc oxide is the oxidizing agent? Because it contains oxygen. So what is the reducing agent here? Reducing agent is the carbon. Okay, now when the reaction happens, what will do? Zinc remove its oxygen, okay, and zinc will be coming as alone. So you will get zinc alone. This is solid substance. Now carbon will combine with oxygen, and the product will be carbon monoxide, COO. So can you locate oxidation and reduction here? What happened to the zinc oxide? Zinc oxide, loss of oxygen. So that is reduction. What happened to carbon here? Carbon gains oxygen and carbon becomes carbon monoxide. So this is addition or gain of oxygen. So this is called oxidation. Okay. So oxidation is the gain of oxygen and the reduction is the loss of oxygen. And zinc oxide is a substance which provides oxygen, so it is the oxidizing agent. And carbon is the reducing agent. Okay, it gains oxygen, so it is a reducing agent. So which means that an oxidizing agent will undergo reduction and the reducing agent will undergo oxidation. Zinc oxide is the oxidizing agent, so it undergoes reduction, and carbon is the reducing agent, so carbon undergo oxidation. Now, one more example I'm just giving here now. Fe2O3, okay, ferric oxide, Fe2O3 plus aluminum. This is actually thermite reaction, Fe plus Al2O3. Okay, so you need to balance it. There are two Fe, put two here. There are three oxygen, Al2O3 oxygen is balanced already. Then we need to balance aluminum. There are two aluminum on the product side, so we need to put two on the reactant side. Now ferric oxide. This is called ferric oxide. Ferric oxide, okay. So it actually contains oxygen. We can call it as oxidizing agent. So ferric oxide is the oxidizing agent. What about aluminum? Aluminum will be the reducing agent. Why ferric oxide is oxidizing agent? Because it contains oxygen. Okay. Now this reaction also we need heat. Okay, just tell me which substance will undergo oxidation and which substance will undergo reduction. Fe2O3 on reaction, the loss is oxygen. Okay, so loss of oxygen here, so that is oxidation. I mean reduction. Sorry, loss of oxygen, so that is reduction. Now, adamant to aluminum, aluminum gains oxygen, so we say it is oxygen, addition of oxygen, so that is oxidation. So addition of oxygen is oxidation and the loss of oxygen is reduction. So ferric oxide undergo reduction and aluminum undergo oxidation. So these examples we already explained in terms of oxygen. Now we can look at some examples in which oxygen is not involved. Okay. So in such cases, how do we determine oxidizing agent and reducing agent, and how do we determine oxidation and reduction? So I'm going to explain some reactions in which there is gain or loss of hydrogen. Look at this example, H2S, okay, it is reacting with the chlorine. Actually, both are gases. The product will be, can you predict the products? Yes, it is HCl plus sulfur. We need to balance the equation, so I'm just putting 2 over here. So this is a reaction between hydrogen sulfide and chlorine, okay, and the hydrogen sulfide will combine with the chlorine to form hydrogen chlorine, hydrogen chloride and sulfur. Now in this reaction actually here H2S, what happened to H2S? H2S actually It has lost its hydrogen. See, and it is converting to sulfur here. So this is loss of hydrogen. Okay, this is called oxidation. Now, what happened to chlorine? Chlorine actually gains hydrogen. So this is reduction. So what is oxidation and reduction in terms of hydrogen? So loss of hydrogen is oxidation and the gain of hydrogen is reduction. Now one more example we can see, that is reaction between H2S and SO2. So this will be reacting and form sulfur and H2. So when you balance, you will get SO2 to H2S we need. So reactant side, then product side we need to H2O. So there will be sulfur 2 plus 1 on the reactant side. So by the time product side we have only one sulfur, we need to balance it as 3S. Okay. So in this reaction, you need to check where is loss of hydrogen and where is loss of oxygen. So loss of hydrogen takes place at the first one. So H2S actually converting to sulfur. So this is loss of hydrogen. So this reaction is oxidation. What happened to sulfur dioxide? Sulfur dioxide lost its oxygen. So this one is reduction. Okay. So loss of oxygen here it is reduction and loss of hydrogen is oxidation. Here we have explained oxidation and reduction in taking two different concepts. We have taken the concept in terms of hydrogen, loss of hydrogen as oxidation, and in case of sulfur dioxide, it lost its oxygen. So that is reduction. Okay, so oxidation and reduction are taking place together. So this is an example of redox reactions.